For the new developments that we have, I would like to defer to the works of Shawn Billings about the new topics. He had done a wonderful job, and I let him to cover it.
Hi, I'm Shawn Billings of Billings Surveying and Mapping in Stumpwater, Texas, and today I'm going to be talking about the JAVAD Triumph LS using the camera offset survey feature. What I want to do is attempt to survey in this steel structure using only the JAVAD Triumph LS and photogrammetry. This steel structure is an oil derrick in the heart of downtown Kilgore, Texas. You can see the steel structure in the bottom center of the screen. Generally, this would be a job for a total station, right? Usually, yes. But not today. So with this JAVAD Triumph LS, mounted on an extendable prism pole with a bipod, we're going to survey this steel structure. After looking over the job site to determine where I need to take the photos, I look for good places to have photo control points, targets that will be visible in the photos. Before I build any artificial targets, I look around for existing objects that would be good for control points. Say, this pipe looks like it would be perfect. It has good visibility to the entire site, and it also has excellent sky view for RTK positioning. With the form factor of the Triumph LS, I can just take the LS off of the pole and put it directly on the pipe post. Now I'll just collect a position here on the pipe post to use later for my photo control. To make this pipe easier to identify in the photos, I'm going to go ahead and put some surveyor's ribbon around the top of it. For this survey, this was the only control point that I created and needed. The camera that's being used is built into the Triumph LS. This is a picture taken from the Triumph LS. It's a 3 megapixel resolution. Zoomed in, this is what the top of the tower structure looks like. That's a very steep vertical angle. The internal tilt compensators and integrated magnetometer or compass allows precise determination of the camera relative to the GNSS antenna, even when tilted. Because of this, I'm able to tilt the camera so that I can get the photo that I need. Knowing the precise location of the camera reduces the need for control points and provides additional redundancy during the adjustment process. Being able to use tilt compensation allows me to get the best perspective of a scene so that I can get the most accurate position of the points. And this is the result. Logistically, I divided this job into 2 projects in the camera offset survey application of JField. I looked at the foundation, and I looked at the steel structure itself. For the steel structure, I created 10 photos, visible here from the Triumph LS screenshot. Within these 10 photos, I created 29 tie points. Here you can see an example of some of the tie points on the screen capture. Zoomed in, you can see a little bit closer where these tie points are attached. Once I had all the tie points created, I was ready to adjust. But upon adjustment, something did not look right. The error estimates are entirely too high, approaching a half a foot or more on some of these points. I must have had an error in one of my tie points. Upon investigation, I found it. The reprojection error indicates that this is the likely culprit. And looking at the photos, I've found exactly where the problem is. This point should actually be up here. Now that I've corrected that, I'm ready to adjust again. And the results? Excellent. The error estimates in feet are very, very low, indicating that I've got a very good adjustment. Now, with these excellent error estimates, I'm ready to export these points to JField and begin the process of looking at the photos for the foundation. In the foundation survey, I collected 6 photos visible in this screen capture. When possible, I was careful to include the control point. Can you see it? Let's zoom in. There it is, CP2. The results were excellent on the first attempt. As you can see, the error estimates are very low. So, how good were the results of all of this? Is the JAVAD Triumph LS with JField a viable choice for this kind of survey? This is an overhead view of the structure in CAD. You can see right away that the symmetry looks very good. The foundation blocks actually measure 2.97 feet by 2.97 feet. The elevations of the blocks range from 356.88 to 357.03, with an average of 356.96. By total station, this was 357.11, which is a difference of only 14 hundredths of a foot. This is a perspective view of the top of the tower in CAD. All of these points were generated from the camera offset in JField. You'll notice that the star has nearly perfect proportions. The diagonal lengths vary from 10.11 to 10.33, and the horizontal line across the star, 463.67 on average versus 463.74 by total station, a difference of only 7 hundredths of a foot. The difference in the coordinates for the tip of the star between Triumph LS and total station, an incredible 19 hundredths in northing, 15 hundredths in easting, and only 18 hundredths in elevation. Perhaps most impressive of all, the overall height of the structure from foundation to the tip of the star by total station was determined to be 110.42 feet. By Triumph LS with photogrammetry, 110.38 feet. I probably won't be able to completely retire the total station just yet, but with the portability of the Triumph LS and the accuracy I'm able to achieve with the camera offset feature, I suspect the total station may stay in the truck a lot more. This has been a Tech Shorty by Shawn Billings, RPLS. Thanks again to Cassie Billings.